In today's note, we're going to look at the line of best fit. So just to recall from the last note, I want to describe the trend and relationship that we see in the scatter plot below, looking at ice cream sales and temperature. So looking at this scatter plot, I should be able to see that the trend is positive. I would say that it is strong, because again, the dots do seem to be close together. And I would say that as temperature rises, so does the sales. Now, what I want to be careful of saying, and that's where the term causation comes into play, because causation means that one variable causes the other. And what I want to be careful of saying is that the temperature causes the sales to increase. And I want to be careful of saying that is because there may be other factors that go into play that maybe I don't see on my scatter plot. And keep in mind that the scatter plot is only looking at two variables. So you want to be careful in saying that one variable causes the effect of the other. So what we're going to be looking at today is estimation. And scatter plots show, we already know that they show a relationship between two variables, and we can use this relationship to help us make predictions about our data. And there are two types of predictions that we're going to look at: interpolation and extrapolation. And what interpolation means is making a prediction or estimation inside our data values. And this is considered more accurate. And if you have trouble thinking of interpolation, you can just think of inter, in, right? So inter means inside, and it is more accurate, and we'll talk about that in a future note. For extrapolation, this is going to be the opposite, and this is when we're making a prediction outside our data values. So this could be outside our highest data value and outside our lowest data value. And this is considered less accurate. So to help us with these estimations, what we want to do is use a line of best fit. And what a line of best fit is that it is a straight line that best represents the trend / data in the scatter plot. So we can see on our graph here, we're looking at temperature and sales. We have a line of best fit in here, and it's that orange line that best represents the trend or the data that we have given to us. And there are a few kind of steps that we want to take into account when creating a line of best fit for our scatter plot. And the one thing is the line must follow the trend. Right? So if it's a positive trend, our line should be going up and to the right. If it's negative, it should be going down and to the right. The second step, or the second thing that we should follow, is that the line should pass through as many points as possible. So again, if it's following the trend, we should be passing through as many points as possible on our scatter plot. And third, there should be an even or an equal number of points above and below the line. Again, you're trying to best represent the data that you see. And finally, the line should pass through points all along the line, not just at the ends. So again, you're not just connecting the first and the last point. You may, but those aren't the 2 points that you're worried about. You're more concerned about connecting points all along the line. So again, these are 4 steps that you should be taking into consideration when you draw your line. It's not something that you're going to be able to check off every single step in something that your line fits, but you want to try to do as many as possible, or keep as many of them in mind or in consideration as you draw your line. So in example 1, Josh gathered information about his age and height from a wall chart in his house. So you can see his age in years and his height. And we want to plot this above data on a scatter plot and label the vertical and horizontal axes. So I'm just going to go down to my scatter plot on the next page. So again, independent would be his age, right? Time is always independent, and the dependent would be his height. So if we go back and look at his points, we could say, okay, so 70 and 1. So at 1 year, he was 70. That's the first point. Oh, before we continue, I forgot to make my title. So we could do something that says like age versus height. Again, just keeping it very basic. So we have our first point. Our second point is 2 and 82. So go over to 2, up to 82. And again, just roughly putting it down. 3 and 93. 4 and 98. 5 and 106. 6 and 118. 7 and 127. And finally 8 and 135. So there's my points for my scatter plot. And if we go back up to B, we want to describe the trend. And the trend is that it is a positive trend. You could say it's strong and positive. Because again, it's going up and to the right. Now to describe the relationship, again, we could say that it's strong. And I would say as years increase, so does the height. Again, we're only talking about what we see, and we're only talking about in terms of a positive relationship. As one increases, the other increases, but we're being specific again about including what variables we have. So now I want to complete the prediction table below. So how old or how tall was Josh when he was 5 years old? So again, I can get this straight from a data point. At 5, he was 106. So he was 106 centimeters. And what type of prediction was this? Because this is inside my data values, this would be interpolation. How old or how tall will Josh be when he is 9 years old? Now this one we can't use because it's not a data point. But what we can do is we can draw a line of best fit. Let's try to do a little bit better. So there's, you want to try to use a straight line as much as you can. So I definitely recommend getting a ruler to help you with this. Because again, if it's not exactly straight, then it is difficult to get an exact value. So I'd say that's close enough. Again, it's not going through all the points, but it is going along through points along that line. I do have a rough number that are above and below, a few that are a little bit above, so this could come up a little bit more, but in most cases this is still just an approximation. As long as it's not completely off and you're in the same ballpark, it should be fine. So if we want to find out how tall Josh was when he was 9 years old, we can go over to 9 years old on the x-axis and then follow this up until we hit our line. Because again, that line is an approximation or an estimation of the trend. So in this case, and then if I go over and I can connect this to my y, the coordinates of this point for at 9, his height should be around 148 centimeters. And this would be considered extrapolation because this is outside our data. Right? If we look at our data ranges from 1 year old to 8 years old. So anything between 1 and 8 years old is considered interpolation. Anything outside of that, whether it's below or younger than 1 or older than 8, is considered extrapolation. So how old was Josh at 100 centimeters tall? In this case, again, we're going to do something similar, but we're going to go along the y-axis. So at 100 centimeters, we're going to go over until we hit the line, and then we can follow it down to the x to see what that value is, and it looks as if it's about 4.5 years. So that means that Josh would have been 4.5 years old when he was 100 centimeters tall, and this would be considered interpolation. Now, you may think that because it's not an actual data value, it's extrapolation. But remember, extrapolation is outside the data, right? So if I look at my data here, I have data from 1 to 8. So anything within 1 to 8 years old is considered interpolation. And the reason it's considered interpolation is because I know what the values were before and what the values were after, so I can predict more accurately what the values in between are, right? I know how tall he was at 4 and how tall he was at 5. So if I want to accurately predict how tall he was in between that, I have a better chance of doing that, say, compared to looking at how much taller is he going to be after 8 years old, right? Because you don't know how tall he's going to grow to. Maybe he hits a growth spurt. Maybe his growth gets stunted. You don't know. And finally, how tall was Josh when he was born? Well, again, using the same idea, when he was born, he was 0 years old. So at 0, I go up until I hit my line. And then I go over to the y, or in this case, it's already on the y. So this would be, I would say, about, say, 52 centimeters. So that means when he was born, he was 52 centimeters tall. And this would be considered extrapolation because it is outside of our data values or the data values that we were given. And again, this would be less accurate because, again, we don't know what he started at. Maybe he started at a smaller height and then hit a growth spurt as soon as he was born. We don't know that. We're just basing our estimations off of our line of best fit. Right, again, a line of best fit is still using, or it's still an estimation or a prediction. And again, that's why predicting inside our data is more accurate than predicting outside our data. So the main thing from this note is, again, just making sure that you have a good idea of what the two types of predictions are. If we move on to our last example, here we just want to practice drawing a line of best fit. So for the first one, say it's roughly something like that. And I would argue that this is a negative and strong trend. In example B, in example B and say it might look something roughly like that. Again, it doesn't have to go through every single point. Again, you have to take into consideration all 4 of those steps that we had talked about previously to help you come up with the best line of best fit. So this would be considered positive, but weak. For C, I would say that there's no relationship. So no relationship, you can't really draw a straight line. So there would be no line of best fit because you don't know what the relationship is. For D, go somewhere along there. This is strong and positive. I think a key thing here is to note that the line doesn't always have to go through the origin, right? Depending on what your graph is or what your data is, it may not go through the origin, and that's fine. If you try to force it through the origin, you're probably going to get an improper line. And then lastly, I would say about that. And this would be weak and negative. So again, the key things from this note we want to get is how to predict using a line of best fit, how to accurately draw a line of best fit for a scatter plot, and what types of predictions we can make using that line of best fit.